This is Unit 3, Lesson 1. So as usual, please look for the tasks to complete from U3L1. You can find it under assignments or again on the Science2 campus homepage in the weekly calendar. You might notice I've updated the weekly calendar now to basically carry us all the way to winter break. Our next unit will carry us that far. First of all, I owe you all an apology. I have not been able to grade your test yet. I apologize for that. I will try to get that done by Friday so that you can see your scores. No guarantees on that, but I'll do my best. And so hopefully I'll have that ready, but we are ready to start off our new unit. As usual, we'll get going with just some random breakout room conversations here real quick. First one's going to relate to the homework, which was posted to the discussion board. So please make sure that you have posted to the Bryson Canvas discussion board on Atmosphere and replied to one of your classmates. Here's the question. What is one thing you found interesting, weird, or surprising from the Bryson reading about the atmosphere? If you don't have anything to offer there, you can share something about your resource, right? What resource did you find and share with classmates there? We'll come back together in about 2 minutes. Breakout rooms are open. Go for it. All righty. Okay, roll back. So, what do we normally see skydivers jumping from about 3 kilometers high wearing? Joseph, what's the one thing you notice?
Parachute.
Yes, parachute would be very important. Make sure you don't go slamming into the ground. You also sometimes see them wearing those like squirrel suits, but you still need a parachute with those. Can't just land with those on you. Good. What else? Go ahead, Nathan.
Wait, can I answer for the high altitude one?
Oh, we'll get to that. So I'll save you for the next one. Sloan, what was an idea just for a normal pair?
Goggles and a backup parachute.
Nice. Yeah, backup is important, but goggles also very important because they're getting tons and tons of wind that they're flying through. Eyes are very vulnerable with that. Jake?
Just stuff like clothing in general to help you with cold because it'll be quite cold.
Yes, there's a lot of wind shear, right, that you're exposed to. And so, yeah, if you're passing through cold air, it can be pretty stressful on your skin. And yeah, they're often wearing bright clothing too, right, to be noticeable. Abby?
Also, like protective headgear, like a helmet.
Yes, hugely important. I know it seems weird to like wear a helmet. If your parachute fails, helmet's not going to help, but it is important and there are chances of surviving. So, Clarence?
I think that was like the foot gear for like when you're landing, like what you need to be wearing around your feet. It's like
Nice.
probably like boots.
Yeah, I know. Yeah, not something big and heavy and clunky. Yeah, I didn't think about that actually. Normally, I guess you see them wearing almost like a kind of like a gym shoe, kind of close, something small. But
Because I was also thinking if you're going down like the way that they land, like they have to be pretty sturdy to like be able to like run with them, like slam into the ground with them.
Yep. Yeah, and then immediately deal with the parachute, right? You want to stick to the ground, not be sliding around. So, all right, now let's think about high altitude. Nathan, what do you want to share about that?
So for my answer in my group, I referenced the world record jump at 36,000 meters, so fairly close. And he had to use a full spacesuit when he did that.
Nice. So why? What are some reasons to wear like a full spacesuit when you're jumping from 39 kilometers up?
No breathable air.
Yes, so no air. Nathan, what else?
It's negative 10 degrees Fahrenheit.
Yeah, so it's extremely cold. We can't breathe, right? The air is so thin. Our lungs are not meant to be breathing oxygen at that low of a density. Abby?
He was also falling like so fast that he barely knew that time was like, or that he was falling in general. So like being able to withstand that.
Yep. Again, it's not something you usually think about, but because the air is a lot thinner, there's a lot less drag. And so they're falling a lot faster, especially initially, right? And so that can be, again, you want to protect your skin and other layers there. So cool. Nathan, do you know who's the name of the world record holder? Do you know his name?
Yeah, it's Felix Baumgartner.
Baumgartner. Yep, we're going to be watching his video today and actually analyzing it in detail. So, Clarence, anything to share?
Basically, well, this isn't like skydiving, but so we're gonna go to like the French Alps for skiing, and there's this thing that you do where you ski off these huge jumps with a parachute, and you like release the parachute, and you use the these like there's like these hot spots of air. So as the hot air rises, it'll like push you up and you'll start spinning. And it's like kind of the same thing of like the idea of like you're going super high up. And then my dad was like, he's done it before. My dad was telling me like the moment that you like move out and you're in like the higher the higher atmosphere, you can like feel it. Like you can feel a very obvious difference like as you keep going up.
Cool. Yeah, riding thermals is something a lot of people like to do. That's really cool to hear about. That's what you see birds doing a lot too. If you ever see birds rising up and they don't seem to be flapping their wings, it's because, like you said, they're riding that warmer air higher up. So very cool. Yes, all right. We are going to be actually watching Felix Baumgartner's jump to explore the atmosphere. So welcome to our new unit. Unit 3 is the atmosphere and climate. It's going to take us all the way to winter break. We're going to learn a lot of chemistry of the atmosphere and gas laws and things like that. We'll hopefully get into a little biology with some ecosystem stuff. And more physics as usual, especially with this initial falling and still relevant drag stuff that we've learned previously. So there's a variety of different things we'll be doing. We'll be focusing on climate change as well, and both the biological impacts and the environmental impacts that it's having. So it should be kind of a fun unit to explore. Homework review, just make sure you've posted to that discussion board. But let's get going. So yes, Felix Baumgartner is the world record holder for highest jump. And so we'll watch a quick little 4-minute video here that kind of summarizes his jump. This was back in 2012, all funded by Red Bull. So you'll see Red Bull logos all over the place. Let me make sure I'm optimized here. Okay. All right, let's watch this. It's pretty crazy watching him step out of this thing when he's that high up.
We got to get Felix off the ground safely and not tear the balloon.
So here we have altitude on the bottom as he rose from 11 kilometers up to 39 kilometers. And I like graphs like this where you're able to split the units so that you can tell temperature is on the right side and air pressure is on the left. It just makes for nicer comparisons and nicer detail in the lines. So some stuff's not so surprising, and some stuff, in my opinion, is kind of surprising. What's the one thing that's a little weird or unexpected, or at least for me when I was first learning about this was unexpected, about this data? What's one trend you notice?
One thing I noticed is there's like kind of weird curves, or like jumps in the temperature, like around, I guess, 29,000, you could say, for altitude. There's a kind of like weird jump there.
Yeah. And, who knows, maybe he's hitting as Clarence was mentioning, kind of like a warmer air pocket that's at higher up. Yeah, there's some interesting, definitely temperature in particular isn't consistent to certain altitudes, right? That there's definitely some weird dynamics going on. Good. Again, take a step back, look at the overall blue line. What happens, right? What changes from when he first started to rise from the last 3 quarters? What did temperature do at the very beginning? Did it get colder or warmer?
Not colder.
It got colder, right? Which to me was not surprising, right? It gets more negative, it gets more cold, and most of you are familiar with the idea that the higher up you go in the atmosphere, colder it's going to get, right? But then what starts happening to the temperature? What happened? Yeah, it warms up, which again, it's still below freezing, right? So it's not anything you would consider warm, but it is becoming warmer, right? It's becoming less negative, which, I don't know, for me was really surprising, right? Because we've already kind of discussed a little bit about how the atmosphere is getting thinner. There's less gas up there. So something's going on with the content or the way molecules are interacting, which is kind of interesting and worth exploring. And so that's something we're going to kind of touch on a little bit. Not surprisingly, what happened to pressure as he rose? Air pressure.
Lowered.
Yeah. Lowered, right? Dropped really quick at first and then kind of, continued to drop, but definitely more gradually as it got higher and higher up. And again, this just means there's less pressure on things overall. This is why, anyone know what often happens to your ears when you're flying in an airplane? Yeah, they pop, right? And that's because with less air pressure outside, right, anything that's contained in a pocket is going to expand. And so, for example, the balloon that Bob Gardner rose with, when he first took off from the desert, it looked kind of measly, right? It wasn't fully inflated. It was this tiny little thing. It's kind of weird to think, that's going to lift the capsule. But if you watch later on in the footage, as he gets higher and higher up, the balloon is much, much larger because there's less air pressure, and so the gas inside the balloon is expanding. It's the same thing that happens inside your ear canal. That's why your ears pop when you're in an airplane, which is slightly higher up. That's also another reason why he had to be in a pressurized suit, right? Or else it would have been super uncomfortable for him experiencing that much less pressure. So all things we're going to explore and look at gas laws and some of the relevant stuff behind that, and cloud formation. It all kind of relates back to this little Bob Gardner jump, so we'll keep coming back to this. And as I said, we'll explore more about his descent when we meet again for our next class. So homework is just to make sure that you have submitted your graph to this assignment, as well as completed the little reflection quiz based on your graph. Otherwise, you're going to start reading Hewitt chapter 26, which is all about the atmosphere, specifically 26.1 and 26.2. But I don't want you to read all of 26.2. You're going to stop at page 761. There's like a 26b that goes into greenhouse effect, which we're going to touch on, but I don't want to dive into that right away. Any usual deal, submit a photo one page of your notes and complete a reading quiz that you have up to 10 attempts on. Questions on the homework? All right, kiddos, that is it for me. Thank you very much. Have a good day.
Thank you.
Thank you.